Hey guys, this is just a little video to review some concepts from chapter 1. I've got 5 problems that I'm going to go through. I'll try to get through them as quickly as possible. So let's just jump right in and start with number 1. So this one looks kind of long, but we'll go through it and it's not actually that bad. It says you want to determine the density of a lump of iron. First, you place the iron on a balance and find that its mass is 25 grams. Then, you fill a graduated cylinder to 30 milliliters with water and add the iron. After putting the iron in the water, the graduated cylinder reads 33.3 milliliters. What is the density of iron? Okay, so this is a lot of words. And whenever you have a problem like this, where there's a lot of words and a lot of numbers, a good thing to do is to draw a picture. Once you've done a lot of these problems, you kind of have a mental image of what's going on, but since this is your first time taking chemistry, a lot of you, it'll really help you to draw a picture. So we know that we are filling a graduated cylinder up to 30 milliliters. So we're just going to mark that that's 30 milliliters with water. And we're putting some iron in there. So there's our chunk of iron, and it's 25 grams. And then after we drop it in there, the water level rises, which makes sense, to 33.3 milliliters. And there's our iron at the bottom. All right, so you need to understand the density. To find density, you need to take the mass and divide it by the volume. Some people call density the Hart equation because it looks kind of like a heart, that mass over volume. Anyway, so the mass of our iron is going to be 25 grams. And the tricky part is the volume. So the volume of the iron, that's what we're looking for, is not 30 milliliters and it's not 33.3 milliliters. It's the difference between those two. Because when we dropped the iron into the water level rose as much as the volume of the iron. So 33.3 minus 30, that's going to give us 25 grams over 3.3 milliliters. And then all we have to do is divide 25 by 33. So we'll just do 25 divided by 3.3 and you get 7.58 grams per milliliter. So that's how you find density when you've got kind of like data from a lab. Okay, next thing you need to know from chapter 1, and this is actually section 1.6, is significant figures. And specifically how to state a measurement using the right number of significant figures. So if you remember, when we measure things, the accurate way to do it is to put down all of the numbers that you are sure of, and then you get to estimate one more digit. So this picture is a graduated cylinder. We want to measure the volume of water in it. So this line is 35, so this line must be 36. So we know that the water level is 36 point something. So we're sure up through this 6. But we get to estimate one digit. So we get to estimate the digit after the decimal point, and I think that's going to be about maybe like 0.4. So, and if this were milliliters, it would be 36.4 milliliters. We get one uncertain digit. Okay, this next one is a little bit trickier. We want the correct measurement for the rectangle. So as you can see, the rectangle is right on the 3. Now, so we know, like, we're certain that it's 3. But we do need to estimate one more digit. What's tricky is that these little, like, tick marks in between 1, 2, 3, and 4, those are the 0.5 marks, but that does not mean that we are now sure of this next decimal point. We could only be sure of it if there were tick marks for every single decimal point. So this one doesn't really help us with our significant figures. We're still unsure of this next decimal point. But we do need to have it because we do need to have one thing that we're uncertain of. So since it looks like it's right on 3, we're going to call this 3.0 centimeters. It wouldn't actually be accurate to just have 3 centimeters because this ruler is accurate enough to have a number after the decimal point. It also would not be accurate to have 3.00 because this ruler is not that accurate. All right, so those are some examples of significant figures. Let's now do a couple of conversion factor problems. I think you will find that these are a lot easier than you guys thought they were at the beginning of the year, now that we've been doing a bunch of them. So, the density of a sample of tap water is 1.057 grams per milliliter. What is the mass of 350 milliliters of tap water? So, we always want to start with what we're given. We want to start with the thing that's not a ratio. This is what we want to start with. This number, the 1.057, that's our ratio. That's our conversion factor. So we're going to put 350 milliliters right here. And then we want to cross out milliliters. So we're going to go 1.057 grams over 1 milliliter. And remember, our units cross out if they're the same on the top and the bottom. And then to get grams, which is what we're looking for because we're looking for mass, and mass is grams, we just need to multiply across the top. So we would just do 350 times 1.057, and we get 369.95. And we don't need to divide by anything because there's just 1 on the bottom. Okay, one more example of conversion factors, and then that'll be the end of this video. Dwayne Johnson has a weight of 118 kilograms. What is his weight in pounds? And here's our conversion factor. So same thing, just set up a chart. We're starting with 118 kilograms. We know that 1 kilogram is 2.205 pounds. Kilograms cross out, and we just multiply across the top. And we get 118 times 2.205. So we get 260.19 pounds. And whenever we're doing these problems, we should think about if our answer makes sense. So does this weight make sense for Dwayne Johnson? Probably, yeah, that makes sense. Yeah, so if you have any other questions, feel free to ask me. But those are some review problems from Chapter 1.